My name is Edmund O'Connor, and I work as the Industry Partnership Manager here in the ADAPT Centre. And just by way of context, I sit as part of the commercialisation team, and that commercialisation team sits as part of the D-Lab, the Design and Innovation Lab here that we have within the ADAPT Centre. Now, that'll be explained in much more detail by Declan McKibben in the next session, who will take you through collaborations and engagements and how we go and have these conversations with industry. But for now, suffice to say, just by way of context, it is that one gateway, that one single access point that industry are able to have that conversation with the research community in Ireland. So we draw on, as was mentioned earlier, domain experts, thought leaders from 8 universities under the one umbrella of ADAPT, and through that gateway simplifies the process of engaging and having those conversations. So we do all the heavy lifting for you. Not the conversations, just the heavy lifting. With that, this morning what we want to do, and by way of context, lots of fascinating conversations earlier in the day about the state of generative AI, responsible AI, talking around sort of regulatory compliance, fundamental rights, ethics, fascinating conversations. What we want to do here is to show those and translate these conversations into practice and showcase 3 examples of case studies that we're currently working on. I'll give you a bit more sort of insight into what we're doing in ADAPT. So I'm delighted to be joined by 3 ADAPT researchers. Each will present their case, and we'll have an opportunity after that for 1 or 2 questions, okay? So first up, we have Professor Donal Sexton, who is a consultant nephrologist and head of the renal department at St. James's Hospital, clinical associate and professor with the School of Medicine, and an ADAPT investigator. Over to you.
Thanks, Edmund, and thanks to Declan and Olivia as well for the invitation to present today. No. This one, yeah. Okay, yeah. Yeah, sorry, so we'll skip on. So yeah, I'm going to talk today about some ongoing work we're doing with ADAPT on the broad topic of AI in medicine, but I'm going to kind of, to keep on time, going to keep it a bit more succinct, but I'm happy to answer any other questions. It's obviously a very broad topic. So I work in St. James's Hospital, as Edmund said, and so it's the largest hospital in the state, the largest teaching hospital, a public hospital, and there's about 1,000 beds, about 30,000 admissions per year. And we have the only hospital that had an electronic health record since 2018. So a lot of data been collected since 2018. What we're worked is ongoing with ADAPT through our collaborations, and we currently have a SFI application in for funding, which, if we're successful, will accelerate this program along with industry partners. So what I'm going to talk about is acute kidney injury. So that's essentially kidney failure. About 1 in 5 people who are admitted to hospital for whatever reason will develop acute kidney injury, which is various degrees of severity from small, mild reductions in kidney function to the severe end of the spectrum where you get complete kidney failure. So I'm a kidney doctor, so I look after patients with kidney failure, kidney transplants, and kidney injuries and high blood pressure. But it can be quite unpredictable who ends up getting a severe acute kidney injury and ending up on dialysis. So this figure on the left here, the picture is a dialysis machine. So if your kidneys completely failed, then you need dialysis to stay alive. And this is what this dialysis machine does. So that's a person's blood going into a semi-permeable membrane. We remove toxins with diffusion and convection, and then we return the blood back to the patient, cleaned of all the various toxins that your kidneys would normally remove. So that's the sphere in the spectrum, but it is quite common in hospitals. So if you're admitted to hospital for any reason, a stroke, a road traffic accident, heart attack, you have about a 1 in 5 chance of developing acute kidney injury. And most, as I say, is mild, but it does end up being severe for some patients. On the top, this is an excerpt from a Nature publication from DeepMind, who have the current gold standard prediction model for this event. And I know last year at this event, Keane Hughes from Google was here, and he's a co-author on this paper. So this graphic kind of shows, is kind of in a pictorial way what we're trying to do in general as kidney doctors. So on the top panel is somebody's kidney function at baseline, and then what we use to estimate people's kidney function in hospital is a thing called serum creatinine, which is a breakdown product of your muscle mass, and it's excreted in a linear fashion by your kidneys. So we use equations based on that to estimate where your kidney function is. And generally, people's kidney function remains very stable day to day. But for people who get an injury, the kidney function declines. So the higher the creatinine, the worse the kidney function. So what tends to happen is you see their laboratory tests becoming deranged over time, their kidney function dropping. But sometimes by the time it's picked up clinically, it can be too late to do anything about it. So there are various interventions you can do to try and change the trajectory and the natural history of it, to try and reduce the severity or prevent it. Mainly changes in medications, treating people's volume status, making sure they're not dehydrated, blood pressure control, and treating underlying sepsis, things like that. But studies to date haven't shown any benefit from these kind of e-alerts, because that's a kind of a complex issue, but I'll talk a bit about it in a few minutes. But this picture from the Nature paper shows very well what the DeepMind algorithm does is give a rollover 48-hour future prediction of the development of acute kidney injury. So the idea is that, as opposed to other models that are out there, it gives advanced warning to the clinical team that this person is at risk of this. So rather than just relying on the change in kidney blood test, which is usually a bit too late, this model uses things like the patient's blood pressure, different various laboratory investigations, demographic investigations, through a RNN, recursive neural network. Well, there are two different models and an X-boosted model as well, XG-boosted. But that is what so this is the paper that Akeen was part of from Google DeepMind. But so initially what we're trying to do is we're building an infrastructure within James's to safely investigate algorithms in a simulated environment retrospectively with data, so that we're not directly impacting patient care right now. But the whole area of AI in medicine is obviously a very broad topic, and is beholden on clinical researchers like myself and doctors and nurses and healthcare workers to study these models to kind of find their best use or their limitations and benefits and what the best applications of them are, rather than ignoring them or trying to pretend it's never going to happen. But also, you know, the kind of integration of these models into clinical practice is a bit further in the future, really, than the media would have you believe, particularly since in the clinical science realm, these are seen really as almost like devices that should be subject to randomized trials. So like any intervention, you know, a medication we give to patients or a device, we need to subject them to randomized controlled trials to see how do they work and do they have a benefit or not. I mean, the field is mainly focused right now on producing the most predictive models, highest AUC, or the best F1 score, or generative AI models, you know, beating different board exams to pass them. But that's a bit far removed from actual clinical practice. There's much more to medicine than just a perfect prediction model, because electronic alerts built around perfect models will just, if they're ignored by the physicians, then they're effectively useless, you know. So initially we're going to use the infrastructure to calibrate the model produced by DeepMind, which is done elsewhere in Michigan. And, you know, I've been involved in data analysis, machine learning stuff for about 10 years. So it's no surprise to me that the model, obviously, and to anybody in the audience, on external validation performed a bit less well than it did originally. But then these group in Michigan were able to tune it to perform well, to perform better. One of the issues was veteran affairs data, which is heavily biased towards males versus females. So we're initially hoping to similarly calibrate that algorithm to the Irish data to see how would it perform in patients coming to A&E in St. James's as opposed to Michigan or the VA system. We're also interested in working with industry partners, and as I mentioned, we have an application with the Science Foundation Ireland. If it's funded, it will accelerate this program, collaboration with the industry partners like Microsoft and OpenAI, and potentially Google as well. But what we're interested in is looking at tabular generative AI. So it may be that tabular AI outperforms these models, but we really need to start studying these tools as clinical decision support tools, because, as I say, you see a publication every week in high-impact medical journals, which are basically built around generative AI models, X, Y, Z, outperforms radiologists, passes this exam, you know, or the USMLE exams, and various different things. But as you get down into more specialized areas, they perform less well. Like in the kidney world, a thing called glomerulonephritis, GPT didn't perform very well in repeatabilities, but there was a lot of potential for this technology to transform medicine as well. But we do need to figure out what the best use of it is, or how best to use it, and to figure out the limitations. But one of the issues with clinical decision support tools is obviously, as we say, electronic alerts traditionally have not really worked very well in clinical practice, because for various reasons. It could be that physician burnout, they just ignore the box. So, you know, in reality what happens is when you're in the electronic record, a box, you know, a red box or an alert system pops up, and just like on your computer telling you about viruses, you know, if you click it and get rid of it, then it's of no use. And sometimes these are generated in the middle of the night with more junior staff who aren't fully sure what to do about it. And there are randomized trials where they've looked at expert intervention, so a nephrologist intervening, but you know, that's okay in big institutions and states, but that's not really generalizable globally, or particularly to under-resourced areas. So generative AI has a lot of potential for that, where you could have a lot more standardized approach to these problems. So hypothetically, if a patient is flagged to being at risk of this adverse outcome, then there's at least some decision support around that, where the person, especially if they're junior in training, can figure out what a standardized approach to that will be. You know, to stop drug X, start drug Y, give fluids, which is what we're hoping to study more fully. And then the other thing, so this paper here I just highlighted because it's the first randomized trial. It was published just in April of this year in the history of the medical literature that showed that actually the implementation of an AI algorithm improved survival. So this was based around ECGs. So it was a CNN developed on about 450,000 ECGs, and then tested in a randomized trial where basically physicians were alerted about, on admission, somebody's ECG, so that's a tracing of their heart, were alerted that this person's at increased risk of dying in hospital. Standard care arm, or with the physicians looking after those patients, weren't given a notification. And the people who were looked after by physicians who were getting text messages to say that they were at high risk of dying in hospital survived more often. When they look back in terms of explainability, and obviously explainability in itself of these algorithms is a different science and lots of errors around that, but the only differences in clinical care that those patients received was that they tended to be admitted to intensive care unit more often, and they tended to have electrolytes replaced more often. So it's hard to explain why that would be, that would be, but it's probably something related to, if you were to guess, closer observation. So people were sent to intensive care units, they'd have one-to-one nursing, a lot more collection of data, a lot more people watching everything and trying to correct it. But it's a seminal article because it is actually the first survival benefit from an AI model in medicine. And so that's what it's work that's ongoing, and we're hoping to get accelerated work around this with some funding from SFI. So happy to take any questions. At the end, sorry.
Thanks very much, Donal. That was great. We'll get a few questions for you. You're not getting off that easy. Well, if there's ever a case study that shows the evolution of AI from general purpose technology in this space to customized healthcare solutions, you know, it's incredible. Do we have any questions from the floor? Don't be shy. Now, just introduce yourself and speak up. Thanks very much.
Thanks for the talk, Donal, opportunity from the Health Research Board. And so it's really interesting to see the evolution, actually, the first pragmatic randomized controlled trial involving this. And I suppose it shows the importance of implementation aspects of the health system that you're working within, the training data. I mean, the biases towards data from men in training data has been a problem to date. So maybe just to flag that we have a secondary data analysis project scheme aimed at people being able to take data that have been collected from other sources and putting them to use in health research applications. And that's the researchers working in partnership with what's called knowledge users, policymakers, but equally could be clinicians, people working in the healthcare system. And that ensures that the developments that are made are in step with what actually happens on the ground in the health system. And the other thing, I suppose, and maybe that's a question for other people that have their finger on the pulse more, my understanding is that anything involved in clinical decision making actually comes under the medical device directive. So you already have to be thinking into the future about kind of regulation and the data that you're collecting from the outset. So I don't know, maybe someone else could kind of comment on that.
Thanks very much. Yeah, no, that's true, and the FDA mandate that as well. So all these in the US, you cannot implement any of these things clinically unless they've been approved by FDA, which means they have to have been subjected to randomized trials. But it's great to hear about the funding opportunities as well, because one of the difficulties in Ireland is obviously we're such a laggard with electronic data when it comes to patient care, and trying to kind of catch up with the rest of the world can be difficult, and then getting somebody or a funding body to invest in an infrastructure. So obviously it's all generated around research questions, but sometimes we just need funding and investment into infrastructure to allow that stuff to happen,
Thanks very much. Any other questions?
This one down the back.
Just at the back there, left. No, yeah, I'll just come around to you.
Hi, I'm the National Librarian for the Health Service Executive, so I'm interested in this. And we provide free access to everyone in Ireland to a clinical decision support tool called BMJ Best Practice, available as an app. So I was wondering if you have any plans to integrate things like this that are useful in an Irish context into existing infrastructure that we have, and we also make other platforms available.
Yeah, no, thanks very much. That sounds fantastic. And I should have mentioned that, we are actually, so Mark Little is here as well, who heads up he's another kidney doctor. We're kind of obsessed with data and stuff, but he chairs the health working group within ADAPT. So we have a system where people interested in healthcare working data meet periodically to discuss collaborations. And we are hoping that if we're successful in this, just having that underpinning infrastructure could spark off a myriad of all collaborations from lots of different angles once we have a nidus of infrastructure to work around,
Thanks very much. I think we may have time for one more question. Or not.
Yeah, I
No,
think
all good. All questions answered. That's great. I should say as well is that the researchers will be staying for the networking coffee after these 3 case studies. So, please feel free to connect with them and ask any questions there. Thanks very much, Donal.
Thanks,
That's
Adam.
great.